Hello everyone, myself Sachin Gaware from RBNB College, Shrampur. In today's lecture, we continue our chapter Permutation Combination from 11th Science. Now, the example is, the problem is, how many 4-letter words can be formed by using the letters in the word Madhuri if there are two restrictions. First one is letters can be repeated and second one is letter cannot be repeated. Now see here, in the word Madhuri there are 7 letters. 1, 2, 3, 4, 5, 6, 7 letters. And observe here, there is no letter repeats. That is, these are all the letters are of different. So we can write here, in the word Madhuri there are 7 letters and all are different, means there is no repetition. Different. Now consider the first sub question, that is the repetition is allowed. That is, repetition is allowed. That is, we can repeat the letter. Now since we have to form a 4-letter word, so consider these 4 positions for the letters. Now there are totally 7 letters available, so the first position can be arranged in 7p1 ways, because here there are 7 alternative places, 7 alternative letters are available to fill the last position. Similarly, we can say that for the third, now since here repetition is allowed, again 7 letters is available, so the next position can be filled in 7p1 ways. Again repetition is allowed, so again this place can be filled in 7p1 ways. Again it can be arranged in 7p1 ways. Since repetition is allowed, so there are 7 ways to fill each position of the letter in the 4-letter words, and so the total words, therefore the total words are equals to 7p1 into 7p1 into 7p1 into 7p1, and we know that 7p1 is a 7, np1 is n, so 7p1 is 7, so it becomes 7 into 7 into 7 into 7. So this can be written as 49 into 49. Now if we take this multiplication, since here 49 into 49, it becomes 81, 9 into 9, 81. So 8, 9 into 4, 36, 36 into 8, that is 44 into, again this is 36, 3 carries, 16 and 3, 19. So 1, this becomes 10, 1 carry, again it becomes 4, 1 carry, 2, 4, 0, 1. So this becomes 2, 4, 0, 1. So when the repetition is allowed, repetition of letters is allowed, there are 2401 4-letter words can be formed. Now for the second one, second sub question, repetition is not allowed. Suppose repetition is not allowed. Repetition is not allowed. Now when repetition is not allowed, again see here, suppose these are the 4 places or 4 positions of the letters. Now initially in the word Madhuri there are 7 letters. Now starting from any one of the sides, suppose start from last one. Now at this position 7 letters are available, so this last position can be filled in 7p1 ways. Now for the second last position, since one letter is used at this position, last position, or you can say first position, remaining 6 letters are available. So this position can be filled in 6p1 ways. See here, we use 2 letters, first here, second here. Now the remaining are 5 letters, and again we can fill 1 letter here from that 5 letters. So here it is 5p1 ways. And lastly again it is 4p1 ways. Since repetition is not allowed, so for the next place 1 letter is less. 1 letter is less. Since first at the starting there are all the letters, 7 letters are available, 1 letter is used here. So for the next position only 6 letters are available. On next position 5 letters are available. On next is 4 letter is available, and so on. We can continue it. So the total words in which the repetition of letters is not allowed are 4p1 into 5p1 into 6p1 into 7p1. That is equals to 4 into 5 into 6 into 7. So this can be written as 840. This to be found to be 840. Or the another way is or since there are 7 letters and we have to make a 4-letter words, that is indirectly we can say that we have to arrange 4 letters from these given 7 letters. So this can be written as, since 7 letters are given, and we have to form 4-letter words. 4-letter words. So which is equals, therefore the total words can be written as 7p4, because since we have to arrange the 4 letters, it means that, we have to form a 4-letter words, it means that we have to arrange the 4 letters, and the total number of letters are given to be 7, and this arrangement can be done in 7p4 ways. Now if we apply the formula for permutation here, this can be written as 7 factorial divided by 7 minus 4 factorial. That is equals to 7 factorial upon 3 factorial. Now if we simplify it, it becomes 7 into 6 into 5 into 4 into 3 factorial divided by 3 factorial. This 3 factorial gets cancelled. So the remaining terms are again 7 into 6 into 5 into 4, and which is equals to 840. So in both the ways the answer is same. We can use any one method, but this is for only when the repetition of letters is not allowed. This is only when the repetition of letter is not allowed. Again, for this one also we can use the formula. That is, when repetition is allowed, that is, if we arrange our objects, remember this one, if we have to arrange R object from given n objects. When repetition is allowed, this can be written as NPR star. And this is equals to n raised to R. The formula for when repetition is allowed is n raised to R. And since here n is 7, so here we write 7 into 7 into 7 into 7. Indirectly, this can be written as 7 raised to 4, since we have to form the 4-letter words. So by using this formula also, you can find the solution or the value for the first, that is when repetition is allowed. The answer will be same. Now consider the next example. Find the number of 6-digit numbers using the digits 3, 4, 5, 6, 7, 8 without repetition. That is, we have to make a 6-digit number by using these digits without repetition. And next question is, how many of these numbers are divisible by 5? The first restriction, that is divisible by 5. The number made must be divisible by 5. Second one is not divisible by 5. And third one is even. And we can add last, suppose it is odd also. Odd one. Now, since there are 6 digits are given and we have to form a 6-digit number. So this can be formed in 6p6 ways, since there are 6 digits are given. So the total numbers, total 6-digit numbers equals to 6p6. Since we have to give on the 6 digits and we have to form a 6-digit number, it means that we have to arrange all of them 6 digits. So this can be done in 6p6 ways, and we know that 6p6 is nothing but 6 factorial. 6p6 is nothing but 6 factorial, and if we try to calculate this 6 factorial, this can be written as 6 into 5 into 4 into 3 into 2 into 1. So it becomes 6 into 5 30, 30 into 4 120, 120 into 3 360, and into 2 720. This will found to be 720. That is, we have to form, we can form 720 numbers, 6-digit numbers. Now, next question is given that first one, from this 720, these are the total numbers. How many of them are divisible by 5? Now, we write here a number divisible by 5. Divisible by 5. Now, we know that a number is divisible by 5. A number is divisible by 5 only if its unit place having a digit 0 or 5. Unit place must contain a digit 0 or 5. Then and only then the given number will be divisible by 5. Now the remaining 1, 2, 3, 4, 5, these are 5 places. These are not important. We have to form a number divisible by 5, so it restricts only with the unit place only. Since the unit place must contain one of the digit, either 0 or 5, so that it will be divisible by 5. Now from this 0 and 5, from the given digits, only 5 is given here, 0 is not given. So this unit place can be filled in 1p1 ways, because only 5 can used at unit place, since we have to form a number which is divisible by 5. Now 5 is placed at unit place. So remaining 5 letters remaining 5 letters can be arranged at remaining 5 places in 5p5 ways. All the remaining these 5 places can be filled in 5p5 ways, and therefore the total numbers which are divisible by 5. So here we write, therefore total number which are divisible by 5, which are divisible by 5 equals to 5p5 into 1p1, and so this can be written as 5 factorial into 1 factorial, which to be found to be 120. 5 factorial is 120. So there are 120 numbers. From these 720 numbers, 120 numbers are such that they are divisible by 5. Now next we have to find B, that is the not divisible by 5, not divisible by 5. Now again, to form numbers which are not divisible by 5, there are 2 alternatives. First one, subtract numbers divisible by 5 from the total numbers. So the remaining numbers are not divisible by 5. So we can write here the numbers not divisible by 5 equals to total number minus divisible by 5 numbers. So this can be written as 720 minus 120. This will be 600. This will be 600. Or the alternate case is, the alternate way is, again, since observe here we have to form a 6-digit number. So this is the unit place 1 2 3 1 2 3 4 5. These are the remaining places. Now a number is we know that a number is divisible by 5 only where its unit place can be filled with 0 or 5. Now we have to form a number which is not divisible by 5. That means that this unit place must be filled by using the digit other than 0 or 5. Other than 0 or 5. And now here the numbers other than 0 and 5, the digits other than 0 and 5 are 3, 4, 6, 7 and 8. That means the unit place can be filled in 1, 2, 3, 4, 5 ways. So here the unit place can be filled in 5p1 ways. 5p1 ways. Now 1 digit is used at unit place. Now remaining 5 digits can be arranged at remaining 5 places in 5p5 ways. So the total words not divisible by 5, therefore required numbers we can say required numbers equals to 5p5 into 5p1. So it becomes, which is equals to 5 factorial into 5, and the 5 factorial equals to 120 into 5, so it becomes 600. The answer is again same one. Now if we consider the third case, that is the even numbers. So number C, suppose even numbers. Now again we know that a number is even, any number is even only if its unit place contain a digit 2, 4, 6, 8 or 0. That is, if its unit place contain even digits, then the whole number is divisible by 2, since whole number is divisible by 2, we know that a number divisible by 2 is the even number. So, to form an even number, the unit place must contain 0, 2, 4, 6, 8 or 0. And from these 5 digits, only 4, 6 and 8 are given here. Only 4, 6 and 8 are given here. That is only 3 alternatives, 3 digits are given. So this unit place can be filled in 3p1 ways. Again, the remaining 5 places can be filled in 5p5 ways. Can be arranged or filled in 5p5 ways. And therefore, the total even number will be 5p5 into 3p1. That is 5 factorial into 3, that is 120 into 3, that is 360. That is 360. 360 numbers are even from the total verse. Now, D, again the odd numbers. Now, the odd numbers are nothing but the total numbers minus the even number. So, odd number can be written as which is equals to total numbers minus even numbers. So, this will be 720 minus 360, so we get 360. We can find 360 odd numbers, 6-digit odd numbers by using the digits 3, 4, 5, 6, 7 and 8. In this way, we can find a numbers divisible by 5, not divisible by 5, and even and odd. Remember here, divisibility. Then the divisibility by 2, that is the even number, not by 2, that is odd number, divisibility by 5, and not divisible by 5 and divisible by 10. These numbers can be found by giving restriction on unit place. Restriction on unit place. And when we arrange the unit place, that is when we fix the unit place, then remaining places can be arranged in any way. So in this way we can find the numbers which are specially divisible by some numbers. We will stop here. Thank you.